In this module, you'll see how verifiable credentials and digital wallets turn identity into an architecture of trust. We'll look at how credentials are issued, stored, and checked, and what this shift means for privacy, regulation, and product design in an AI-driven world. Digital identity is shifting from vulnerable silos to portable, user-centric truth. In the old model, each organization stored its own copy of your data. That led to password overload, data lock-in, and large breach targets. Your identity was fragmented and hard to move. In the emerging model, credentials act as secure, reusable building blocks. Cryptography lets you prove specific facts about yourself selectively to many parties, without handing everyone a full copy of your data. Underneath that shift is a simple trust triangle. First, an issuer you already trust, like a bank, school, or government, creates and cryptographically signs a credential about you. You, as the holder, store that credential and decide when, where, and which pieces to share. Then a verifier, like a new app or service, checks the cryptographic proof so it can trust the claim without calling the issuer every time. A verifiable credential is a structured, signed statement about someone that software can reliably understand and check. At the top is metadata, who issued it, when, and for what purpose. In the middle are the subject claims, such as your name, age, or degree. At the bottom sits the cryptographic proof, usually a digital signature. If any claim is changed, that signature no longer verifies. That makes the credential tamper-evident and trustworthy across different systems. You can think of a digital credential like a passport for a specific claim. A trusted issuer first checks your identity and signs a credential about you. You then store it securely, usually in a wallet app you control. When needed, you present only the pieces a verifier is allowed to see. The hardest part is revocation, making sure verifiers can reliably tell, in real time, whether something that was valid yesterday has been withdrawn today. Cryptography is what makes verifiable credentials scalable as a trust mechanism. An issuer uses a private key to sign a credential. That private key never leaves their control, so the signature effectively binds their identity to the data. Anyone can then use the corresponding public key, typically published in a registry, to check that signature. If even a single field is altered, the math breaks, the signature fails, and verifiers immediately know the credential has been tampered with. Digital identity wallets are the control center for your credentials. Instead of separate logins and stray PDFs, your passport, diploma, or gym pass can live in one secure app. The critical component is key management. The wallet protects your cryptographic keys and offers encrypted backup and recovery. So losing a device doesn't mean losing your identity. When we talk about trustworthy identity, we're really talking about UX, consent, and transparency working together. Users should clearly see who is asking for data, exactly what will be shared, and have an easy way to say yes or no. Defaulting to minimal data sharing and keeping a visible history of every access request turns consent from a one-time click into an ongoing auditable relationship. Digital identity isn't one market, it's the connective tissue across many. In government, verifiable credentials streamline age checks and high-assurance citizen services. In education, they turn transcripts and micro-credentials into instantly checkable proof, reducing background check delays. For licensed professionals, cryptographic credentials let boards and employers confirm someone really is who they claim, with the right certifications. And in healthcare, verified identities and prescriptions help reduce fraud and automate compliance, while still protecting sensitive data. Mobile driver's licenses are one of the clearest examples of digital identity going mainstream. They're standardized, cryptographically protected versions of your plastic license, designed from the start for cross-border use. Global standards aim to make them readable by many countries, and importantly, they can still be verified offline at a border checkpoint. Traditional identity checks work like shouting your whole biography just to prove one detail. To show you're over 18, you leak your full name, exact address, date of birth, and often an ID number. That's over-disclosure by design. The emerging model flips this. You prove a specific fact, like over 18 is true, without exposing everything else. Architecturally, that's the core promise of selective disclosure and privacy-preserving credentials. Zero-knowledge proofs make that selective disclosure possible. They let someone convince a verifier that a statement is true without revealing the underlying data. Imagine proving you're over 18 without sharing your exact date of birth. Your device runs a cryptographic protocol locally, using your hidden data, and produces a proof. Anyone can run a public algorithm on that proof. It returns only yes or no. Crucially, each proof can be unique, so verifiers can't easily correlate you across different interactions. In regulated environments, privacy isn't absolute secrecy or full exposure. It's a controlled balance. Day to day, systems should reveal as little as possible, using techniques like zero-knowledge proofs or minimal attribute sharing. At the same time, regulators still need tools for investigations. That's where tightly governed, lawful de-anonymization comes in. Exceptional access under clear legal orders with audit trails and oversight. The real design challenge is encoding that balance in your governance framework instead of leaving it to ad hoc decisions. When you evaluate digital identity wallets, zoom out from the tech and ask 3 questions. First, governance. Who gets to be trusted? Who runs the trust lists? And how does recognition work across borders? Second, security versus user experience. How do people recover from a lost phone or key without introducing backdoors? Third, ecosystem risk. If a few platforms own the main wallets, you may have just traded centralized servers for centralized devices. We're moving from a world of fragile passwords and scattered data toward identities that are cryptographically anchored and portable. At the center sit verifiable credentials. They let you prove specific facts without handing over everything about yourself. AI raises the stakes by making fakes cheap and convincing. That's why mathematically verifiable credentials become the anchor of trust, so we can reliably tell what's real, what's authorized, and which actors are actually human.